One place where De Morgan's law is important is when thinking about the conditions in while loops or do-while loops. So a while loop will continue to iterate, it'll continue to loop as long as the condition up here is true. So I think of this as the continuation condition. It's like an if statement that will decide, should we continue for one more loop? So there's two skills I want you to know. One is, could you test individual values and decide, is it going to loop? The other is using De Morgan's law to take the continue condition and translate it into a stopping condition. What would actually have to be true to make it stop? So let's do each skill. Okay, so if I was just going to read this in English, I would say, keep looping while a isn't 1 or a isn't 2. So that makes it sound like it's going to stop if a equals 1 or if a equals 2. So let's actually test that idea. Let's think about what would happen if a equals 1. So I'm going to rewrite the condition here, but as an if statement, and then we'll think about each part. Okay, so if a equals 1, is it true or false that it is not equal to 1? You got to think about that for a second. Let's say it one more time. If it is 1, is it true that it's not 1? And clearly the answer is no. It's not true that it's not 1 because it is 1. Okay, so let's look at the other part. This is the or symbol. So if it equals 1, is it true that it is not 2? The answer there is yes. So here we've got false or true, but you remember that the or operator is true if either one of these two things are true, or if they're both true. So overall, this evaluates to true, and because it was happening in a while loop, that means that we're going to continue to loop. So notice that what actually is happening is backwards from what we thought was going to happen when we read it in English. It sounded like keep looping as long as it's not 1 or not 2. So if it's equal to 1, it sounded like it should stop, but we can see that it's actually going to continue. You can try it yourself now for a equals 2. Go ahead and pause the video, give it a try. So similarly, if a is 2, then it's not true that it's not 2. But it is true that it's not 1. And as long as one of these two things is true, we're going to continue to loop. So if you can step back and think logically, we know that at least one of these two things is always going to be true. It's always going to be true that it's either not 1 or that it's not 2. So what this tells us is that this is an infinite loop. So there's actually, it's sort of a bad while loop. There's no condition that would ever cause it to stop. Okay, let's think about the other skill, which is to translate the continuation condition into a stopping condition. So continuing and stopping are opposite. If I am not stopping, I'm continuing. If I'm not continuing, I'm stopping. So let's take the continuation condition, and I can say, if it is not true that the continuation condition is happening, that must mean that we're stopping. So you can find the stopping condition just by negating the continuation condition. Okay, but how do we think about the stopping condition? This says it's not true that a isn't 1 or a isn't 2. So this is where De Morgan's law comes in. You can simplify this expression by kind of distributing the not symbol in. And so we know that that should be equivalent to a equals 1, a equals 1 and a equals 2. So the stopping condition is a has to be 1 and 2 at the same time. And clearly you can see that that's impossible. And that's just a different way of seeing why this causes an infinite loop, because the stopping condition that would logically have to happen is one that can never be satisfied. Okay, so this was sort of an abstract example, like what is this a? What does it represent? Why do we have this stopping condition? So now let's look at a couple of real-life programming scenarios where it would be very easy to write the wrong loop condition. And what I want you to do is think through, could you test a value to see, does the loop condition make sense? Could you translate into a stopping condition to see if it makes sense?